Well, good evening, church. Good to see you here tonight. Thank you for having me. Thank you for being here, especially if you are an atheist, if you are an agnostic, someone that is questioning God. Thank you for being here. Today's lecture is going to be a little bit interactive at some points. Feel free to answer out. Feel free to raise your hand if you have a comment or a question. But we don't have a lot of time for introduction, so we'll get straight into the lesson. I am trained in mechanical engineering. That's where my undergraduate degree is from. I have a master's degree in progress. But currently I also work as an engineering consultant for various electric utility companies around the world. Most of that work has been in the Tennessee Valley, South Carolina areas. But the reason I give those credentials is not to show that I'm some type of authority or show that I'm some type of special, but that I want to show you that you can study God's creation as a Christian and learn His nature. You can study God's creation as a scientist and learn about how that creation reflects the very nature of God. Many in the world would say that if you're a scientist, you have to turn off the Christian part of your brain just to engage in science, just to engage in that observation and conclusion process. Many on the religious side would then say that you can't be a scientist because that's the devil's work. Science has disproven God, and therefore a Christian, someone that's religious, someone of faith, cannot be a scientist. I hope to show you, and that's my prayer this evening, that you can study God's world and learn about Him. During the past hurricane, I have a co-worker that lives in Asheville, North Carolina, and he had to evacuate. Immense flooding, I'm sure you've seen it. But throughout that whole event, I found myself wanting to know about his situation, wanting to know about the people there that were burdened by this flooding. I found myself wanting to ask questions and know more about his specific situation. And perhaps you've done the same thing as you've seen Facebook posts about my daughter lives in Chimney Rock or my son-in-law lives in Asheville and they need this or that. Perhaps you've seen about the local churches and preachers in those areas. And after services today, we're going to spend about 20 minutes or so meeting new people, greeting, shaking each other's hands, learning about the area that you're from, learning about the area and seeing if they know people that I know. We seek to know more about the events and the connections that we have in our life. And even if we're not religious, we stop at that interstate mountain overlook and we take the beautiful mountain picture. Or we sit on the Atlantic coast on the beach for hours trying to get a nice sunrise picture. We want to know more about nature. We want to know more about our bodies. We want to build muscle and then keep our hearts beating as strong as possible. We want to know more about how to keep the extra weight off. And we want to know more, after all of that fails, how the doctors are going to help us in surgery and medicine and all different types of diagnoses. We spend a lot of time wanting to know our bodies. And we spend a lot of time wanting to know the animals around us. We have dogs and cats and fish and reptiles in our own homes that we treat like members of our family. We give them names and we talk for them and give them different type of characteristics that we think they ensue. We sit in the woods for hours learning about how to track the big buck that's been eluding us for the past years. And we learn all about how deer react to sound and sight and vision, and we want to know more about how that works. We give our money and time to aquarists and those who work in zoos to protect endangered species for us because we don't want them to go extinct. We like to know more about them. And we look up at the stars and we see the beautiful sculpted patterns that even we can make out around us. And then we spend a lot of time looking through telescopes up at the stars into the vast space. And then when that fails, we build an $18 billion telescope to send out further than you could even imagine. We want to know more about the things around us. In fact, in our history, we've always wanted to know. 3000 BCE, the Mesopotamians were busy wanting to know more. 5,000 years ago, they were wanting to know more about astronomy, about math, about medicine. They were busy inventing calendars based off of lunar cycles, and the Egyptians were busy creating land survey landmarks. 600 BCE, the Grecians were busy wanting to know. Aristotle created a systemic approach to observation, which we now call science. He's the father of science, we would say. They were busy wanting to know about leverage and buoyancy, something that has governed shipmaking since then. And in the past couple of centuries, we've really been busy wanting to know. We've been wanting to know about quantum mechanics. That's what most of our focus has been on in physics, is wanting to delve into the atom, into the very construction and metaphysics behind it, and learn about the smallest part of our universe. But we've also been very interested in knowing about deep space and learning the very vastness of our universe. We want to know more about all types of things. We want to learn about nature, our bodies, animals, rivers, oceans, stars, galaxies, solar systems, and our universe in every meaning of the word. And so we look into our world seeking to know, seeking to understand its nature, and we don't often find those answers. But yet the answers we find, I think, point us towards something, and that's what we'll be looking at this evening. In Romans chapter 1, Paul would say in verse 19, Romans chapter 1, since what can be known about God is evident among them, because God has shown it to them. For his invisible attributes, that is his eternal power and divine nature, have been clearly seen since the creation of the world, being understood through what he has made. As a result, people are without excuse. The Bible's claim, Paul's claim, is that seeking to know is baked in. God has created us with the ability and the desire to see his creation and learn about his nature. He's created us with the ability and the desire to see nature and learn about his nature. All people everywhere have seen the nature of God simply by existing. Seeking to know the invisible attributes, seeking to know the things around them in whatever scale that may be. And so the Bible's claim, Paul's claim then, is that seeing those invisible attributes, they know God. What are some invisible attributes that you can think of when you view the vastness of space or the beautiful mountain overlooks, or you think about your own body? What are some of those invisible attributes you think about? Yeah. His knowledge, his intelligence. That's why we call it intelligent design. There has to be something smart behind it.
The immutability and constant of his laws.
Yeah, his nature does not change. And we're told all the time that change is driven by evolutionists, but yet what we see when we actually look into nature is nature does not change all that much. What else?
Is love, in that the creation provides for us, and that we're able to be sustained by it.
Yeah, good. His love, and we see that by his provision. We'll be talking about that tonight extensively.
The order of everything, how you can look out into space and everything is in order, or if you look down to the smallest atoms and break that down, everything has order to it. It's not chaos.
Yeah, order. We'll be discussing that tonight as well. Everything has a place, and it seems to all fit together so perfectly, even in the magnificent scale of it. And so if everyone has the ability and the desire, thank you for those attributes, we'll be talking about many of them. If everyone has the ability and desire to see those things, to be able to know God, why don't more people know God? This is a question that's not new. During the height of the philosophical period of Greece, when it was called Achaia, Paul traveled to a city called Athens and found a people which he called religious in every respect. But yet none of them knew the true and living God. A people who knew God, but yet Paul would say they didn't know God. So you can turn in your Bibles to Acts chapter 17. We'll be taking some thoughts from there. In Acts chapter 17, Paul is on his second missionary journey when he stops at the city of Athens. In verse 16, while Paul was waiting for them in Athens, he was deeply distressed when he saw that the city was full of idols. So he reasoned in the synagogue with the Jews and with those who worshipped God, as well as in the marketplace every day with those who happened to be there. Some of the Epicurean and Stoic philosophers also debated with him. Some said, "What is this ignorant show-off trying to say?" Paul finds a people in the city of Athens who worship, and they want to know more. He finds a people who worship in the synagogue, the Jews. He finds a people who worship in the marketplaces, the Stoics, the Epicureans, the philosophers of the day. And those two groups were extremely prevalent, not just in Athens, but in all of those who would have this Platonic philosophical thought behind them. The Epicureans would have thought that happiness is the quintessential point of life, and by getting happiness, you must live a simple life, a moderate life, and a friendly life. On the other side of the coin, the Stoics would have thought that virtue is the quintessential point of life, and that you get virtue by being a good person. Athens was full of people who studied life and nature and knew God, but they did not know God. These are a people who knew the simplicity, the moderation, the friendship, the virtue, and the goodness from the nature around them of God. And so Paul would then continue in this journey in verse 19. They took him and brought him to the Areopagus and said, "May we learn about this new teaching you're presenting? Because what you say sounds strange to us, and we want to know what these things mean." Now all the Athenians and the foreigners residing there spent their time on nothing else but telling or hearing something new. Paul stood in the middle of the Areopagus and said, "People of Athens, I see that you are extremely religious in every respect." And so these people that want to know more, want to know about Jesus and the resurrection, they take Paul, the preacher, up to the Areopagus, up to the place of distinguished thought of the city, the place of debate, the place of trial, a place of rigorous study and thought. And Paul says that these people were religious in every respect. It is no wonder why he says that. As he stood on the peak of Mars Hill on the Areopagus, he would have looked behind him and he would have seen the temple of Hephaestus. He would have seen the Stoa of Adelos. If he turned to his right, he would have seen the temple of Zeus, halfway constructed by the Romans on Olympia Hill. If he turned to his left, he would have seen the Agora and the altar of the 12 gods, and as he looked up in front of him, he would have seen the Propylaea, the Erechtheion, and the temple of Athena Nile. And on the pinnacle, on the very top of the hill of Athens, he would have seen the Parthenon in its beauty and grandeur, overlaid in gold and bronze and painted beautifully. All we see today is the marble behind it. And over top of the Parthenon, he would have seen Athena protecting what they thought was her city, protecting her people, they thought. And so you see, Paul preached then in the midst of a very perceptive people who failed to fully find God. But, Paul says, they were religious in every respect. What is the solution then to being able to look out into this world and know that there is more, but not knowing the more? What is the solution to being able to look and see all of these different nature of God, the friendship, the moderation, the goodness, but not knowing who's behind that nature? If you keep reading in verse 23 with me, Paul would continue, "For as I was passing through and observing the objects of your worship, I even found an altar on which was inscribed, 'To an unknown God.' Therefore what you worship in ignorance, this I proclaim to you. The God who made the world and everything in it, he is Lord of heaven and earth." Paul says the gods you worship don't match the nature that you claim to know, the friendship and the goodness, the moderation of gods. Paul's solution to being able to know the nature of God and know God is to learn about the beginning, to learn about his creation. This is the God, the Lord of heaven and earth. So that's what we're going to do tonight. That's what Paul says to do to these perceptive people who fail to fully find God. And so we're going to do the same. We're going to look into the beginning. And so you can turn in your Bibles to Genesis chapter 1. Genesis chapter 1 is the beginning. It is the beginning story. And by studying the beginning, we will see that God is behind it all. Not just God, but a God that is not like us. Where else is better than Genesis chapter 1 to learn about the beginning? Genesis chapter 1 makes the extraordinary claim that our universe has risen out of nothing, from nothing, only by the power of Almighty God. In the first two verses we read, "In the beginning God created the heavens and the earth, and now the earth was formless and empty. Darkness covered the surface of the watery depths, and the Spirit of God was hovering over the surface of the waters." In the very first sentence, we get four qualities of God, his nature. We see that God is alive in the beginning. There's one beginning, and it is the one that God is in now. God didn't create our world and go to a different world and create a separate reality, a separate universe. God is alive. We see that God is eternal in the beginning. Our world had a beginning, and if he created it, he had to have been before it. God is eternal. And we see that God is intelligent. He's smart. In the beginning, God created. If God created all that we see and know and feel and touch, who else? Who else could have done it? He had to have been intelligent to create. And we see that God is creative. By the very nature in the beginning, God created the heavens and the earth. By his very nature of creating, we learn that he is creative. And by learning these things, we learn that this is a God not like us. This is a God that we did not construct, that we did not form in our image. This is a God that has extraordinary and magnificent qualities and nature behind him. And so as we read through the Genesis story, let's remember that what we're looking at is a God not like us. On day 1 in verse 3, "Then God said, 'Let there be light,' and there was light. God saw that the light was good, and God separated the light from darkness. God called the light day, and the darkness he called night. There was an evening, and there was a morning, one day." God is authoritative. On day 1, God creates light, and then he's able to separate the light from the darkness. Where did this light come from? Yeah, no source. No source. That's what we'll see on day 4 as we keep reading this account. But what's interesting here is that what we know about light now is in order to have light, in order to shine light, you must have the source. There must be a source for the actual particle to flow in the air. And of course that's also a wave, but yet here God separates the particle from the wave. God is authoritative. He speaks light into existence. His word commands reality and brings forth nothing but order from the chaos that existed. And we see that God is illuminating. God has separated here the very laws of nature as we know it and has demonstrated complete control of them. And we see finally, and most importantly I think, is that God is good. His intrinsic goodness is evident by him creating light. In fact, as he creates it, he says that the light was good. His intention is for his creation to reflect his nature, his creation to reflect his qualities. On day 2 in verse 6, "Then God said, 'Let there be an expanse between the waters, separating water from water.' So God made the expanse and separated the water under the expanse from the water above the expanse. And it was so. God called the expanse sky. Evening came, and then morning, the second day." God creates here an expanse between waters, what some translations will call a firmament, water above and water below, and he creates the sky, the air, the atmosphere. Our sky is usually overlooked by us most days. We don't really think about it too often. We don't think about, I need to breathe in some atmosphere. I mean, we just breathe. It is, though, a most fascinating and elusive topic. Let me give you an example of this. In fluid dynamics, we study the flow of fluids, which air is. If you didn't know, it is a fluid. Not a liquid, but it is a fluid, just like asphalt, silly putty, our blood. And we classify the movement of fluids in three different ways. The first is laminar flow, which is a very straight flow, easygoing flow. There's no mixing. It's smooth and steady. And then we have turbulent flow there. It's chaotic, transient, mixes. Think about a hurricane spinning in the Gulf of Mexico. And then you have somewhere in between, which we call transitional flow. These classifications are extremely important to use as engineers. We spend lots of study and engineering to design our systems with the fluid flow characteristics that we want. The perfectly streamlined edges of an airplane and its angle will determine if you get to your destination or you fall out of the sky, as you'll see in a second. Here you'll see a boundary layer starting to form, kind of like a sticky friction on the surface, and as soon as the angle of attack gets too much, the boundary layer will separate, and now we're in what you call stall, and you're out of the sky. The classification of these different types of fluids, laminar, turbulent, transitional, is governed by a dimensionless variable which we call the Reynolds number. The Reynolds number is something that most engineers learn, and then that's just what they use to classify the fluids. There's not much thought behind it. But Reynolds number is actually a very interesting discovery of the nature of our universe. Reynolds number tells you the inertial force, or how much a fluid wants to flow. Think about like voltage and electricity. How much a fluid is pushing, so we'll call it the pushing force. And that is compared and divided by the viscous force, how much resistance there is to the fluid, how much the fluid doesn't want to flow. And so the pushing force, the inertial force, is the object's or fluid's density multiplied by how fast it's going and the amount of length it takes for the boundary layer to fully develop. The viscous force is viscosity. Viscosity is the determining factor of if your honey needs to go in the microwave before you put it on your biscuit or whatever it is you're eating. Honey's very thick, water's very thin. Different types of fluids have different types of viscosity. And it is increasingly difficult for us as engineers to design systems, and this is just a fraction of the things that are considered, to design systems according to these physics. We'll take up entire rooms at manufacturing plants to get flow to the right speed, to the right temperature, so the density is affected. We'll spend all that room finding the right boundary layer characteristics just for one fluid, in one pipe, and one in and out. If you don't believe that our creation is well ordered and designed, I want you to think about your lungs. Think about how much fluid flows into your lungs every day. And it is a machine better than what any of us could ever come up with as engineers or scientists. Your lungs are made up of four main structures. You have the trachea, which goes down from your throat, and then that trachea splits off into both lobes into the bronchial tubes, and those bronchial tubes are smaller than the trachea, but not by much. And then it goes and branches even further into bronchioles, and those are pretty significantly smaller in diameter, and then it breaks up into what makes up most of your lung mass, these bulbous structures called alveoli. These alveoli are about 200 micrometers in diameter. That's 200 1,000th of a millimeter. Far too small to see with your eyes, but there are about 480 million in an average small adult in your lungs. Alveoli are surrounded by the same number of tiny capillaries, and they're both about 1 cell in width. That's because the alveoli's entire purpose is to carry away CO2 from your deoxygenated blood and then to add the O2 oxygen back into it for cellular respiration. And as it turns out, these tiny structures are perfectly designed in order to do so. And not only are the lungs perfectly designed, but the air around us is perfect for our lungs. to keep us alive. Imagine breathing in maple syrup, or imagine going to a mountain at 20,000 feet above sea level and trying to breathe there. Different properties of the atmosphere will cause you to breathe differently. And so one of the ways that engineers control fluids is through modulating its properties. Properties like velocity, how fast the fluid is moving, and its pressure, how much force it wants to push out. Like we said, the pushing force. If you have a pipe with an initial velocity and initial pressure starting out to flow, and then you start squeezing and constricting it, what you'll see is that all the time the speed of the fluid will increase and pressure will decrease. As you constrict the flow, think about your air compressor. As it goes out of the nozzle, that fluid is very fast coming out, and that's because that nozzle is constricting the flow and dropping the pressure suddenly. And remember that if you want a nice, orderly laminar flow, which we want in our lungs to aid in breathing, you want a low inertial force. You want a low velocity and a higher pressure. And so by rapidly increasing the area of flow into those millions, hundreds of millions of alveoli, air is slowed from hard breathing from 26 miles per hour to just 0.0002 miles per hour, decreasing Reynolds number and allowing for a nice laminar flow into all those tiny little bronchi throughout your lungs. The whole point, again, of our lungs is to get oxygen in and CO2 out as efficiently as possible. And so as air reaches those bulbous structures, the alveoli, they actually expand. You can feel it as you breathe in. They actually expand pretty rapidly. And that further decreases the velocity because the area is once again increasing. And that will rapidly increase the pressure at those capillary walls, and that allows for a pressure differential. So what you'll see is that oxygen will actually come into here, it will expand, velocity will decrease, pressure will increase, pushing on the wall of this so the oxygen can go into the blood, and then CO2 will exit the blood, allowing for cellular respiration. Our lungs are perfectly suited for our atmosphere. And you could say it the other way around. Our atmosphere could not be different, could not be any level more viscous, more inviscid. It's perfectly created. What we see on day number 2 is that God is orderly. By separating the waters and creating the most perfect atmosphere, God values order. He values structure. And what we also see is that God is sovereign. All of these different properties we just talked about, God creates right here on day 2. He speaks them into existence, and then he divides his creation. And then not only does he do those things, but demonstrating his complete sovereignty, he names them, gives them purpose and meaning. On day number 3, in verse 9, then God said, let the water under the sky be gathered into one place, and let the dry land appear. And it was so. God called the dry land earth, and the gathering of the water he called seas. God saw that it was good. Then God said, let the earth produce vegetation, seed-bearing plants, and fruit trees on the earth, bearing fruit with seed in it according to their kinds. And it was so. The earth produced vegetation, seed-bearing plants according to their kinds, trees bearing fruit with seed in it according to their kinds. And God saw that it was good. Evening came, and then morning, the third day. On day number 3, God creates the seas and the earth and the vegetation. By lowering the sea, the earth will come up, displacing more sea, creating dry land and allowing vegetation to come up on it. And we looked at fluid dynamics to help us better understand God's nature on day 2. And here we're going to take a lesson from structural mechanics. Structural engineers are pretty jealous of the genius design behind trees. Something you probably don't even think of most days. The aft section of trees are designed much thicker, and you'll see that at their trunk. and the forward section are more thin and flexible. That allows them to move and sway in the wind. And so when our structures fail, as I designed those, it's pretty sad to see trees standing right next to it. As much as we try to design the best of our abilities, God wins in that design. And so this design, where trees can sway in the wind, where they have a thick, strong base and then a more flexible, skinnier top, this design mimics the natural laws of physics perfectly when you consider the stress-strain curve. Material goes under a stress, will strain at the same time. The stress on a tree generally comes from wind, and that would measure the force of that wind applied over the entire area of the tree. The strain of the tree is the amount the tree stretches or bends in response. And so you can see for most materials, crystalline materials, as a material stresses, it will also strain in this region we call the elastic region. And that's governed by a slope called Young's modulus. All materials have that number. That is how you decide what steel or what aluminum to use in a certain project. But with light wind, the stress-strain curve stays again at that region. For trees, the elastic region. But the more stress, the more the wind blows, the more bending. But it can still probably spring back to its original shape. But as the wind gets stronger, the stress gets more. It will reach the yield point, which is right here, and it will start to continuously deform if any more stress or wind is applied to it. The ultimate strength is the maximum stress the tree can handle before it weakens and breaks significantly. And then as more and more stress occurs, it will strain more, and it will ultimately reach the fracture point, which requires less stress than the ultimate strength of the material. And so the fracture point is where the tree is going to break or snap in half. Trees don't just bend once, though. They constantly bend thousands of times in the wind per day. Have you ever taken a paper clip and kind of fidgeted with it, and it'll eventually get real hot and then snap apart? That's what we call fatigue stress. And so trees undergo a fatigue stress all day long, all night long, and you don't even realize it. And so that fatigue stress, just like with the paper clip before it gets ready to break, forms tiny little cracks in the material that are formed from that repeated stress strain, and anywhere past the Young's modulus or elastic region, anywhere through here. Normally, these tiny cracks lead to catastrophic failures in engineered solutions. In 1834, there was a train that had been going without maintenance for a while, and I want you to think about train wheels connected via an axle with no type of differential on it. Those train wheels kind of go over bumps all day long, and constantly they're bending and shifting. And so in 1834, that axle went under a fatigue stress and snapped right in half. Hundreds of people died just because of an axle breaking. And so we would think then, if it's very easy in our world when we design stuff for all different types of stuff to break from fatigue, well, it turns out trees don't break from fatigue all that often. They actually are able to heal those tiny fatigue stress cracks through a process which I'm not confident is thigmomorphogenesis, where the trees can grow rings, and those rings will actually fill those cracks in with cellulose, which is what wood is made out of. It's kind of like a fibrous material. And then in the same way we add rebar to concrete to increase its tensile strength, trees do the same thing as they grow each year with additional rings. A marvelous example of God's provision. God provides for His creation. He's not letting His creation go without Him. God is the great provider. The emergence on day 3 of dry land and the grand engineering behind all of the diversity of plant life. That's one example. There's all types of plants in our universe. God also divides here on day 3. He divides On day 1, the light from the darkness. He divides on day 2 the waters above and the waters below. And here on day 3, he divides the seas from the dry land. We'll think about that later. On day number 4, in verse 14, then God said, "Let there be lights in the expanse of the sky to separate the day from the night. They will serve as signs for seasons and for days and years. They will be lights in the expanse of the sky to provide light on the earth." And it was so. God made the 2 great lights, the greater light to rule over the day, and the lesser light to rule over the night, as well as the stars. God placed them in the expanse of the sky to provide light on the earth, to rule the day and the night, and to separate light from darkness. And God saw that it was good. Evening came, and then morning, the 4th day. Here on day 4, God creates the sun, the moon, and the stars, but he also does something he's already done. Can you guess what that is? He provides a source for light, something else. On day 1, he creates the light, and the light is separated from darkness. Here on day number 4, why does God need to do that again? It says in verse 18 to rule the day and the night and to separate light from darkness. Didn't God already do that? Why does he create on day 4 a source and separate the darkness? Is it for him? Is it for his well-being, his nurture, his provision? Or is it for his creation's provision? If you doubt that there is wisdom in the way that our years, days, signs, and seasons are laid out, then you need to spend more time with a farmer in his land. Because our seasons are perfectly balanced for our creation. Think about this hurricane that just came through. What was up on the banks and in the buildings and in people's flooded houses that you saw on the news from that river? It's covered in something. Silt, mud, sediment. What's in that mud? Nutrients, life. I like that answer. Every season, every rainy season, sediment is overtopped on banks, on river banks, and for thousands of years now, farmers have known that's where you go to plant your crops, because that soil is gold. There's wisdom in the way God creates, but God is also magnificent. Our universe, to what we can even measure, as it currently expands, is 93 billion light years wide. You have no clue what that means, and neither do I, because we don't work with light years. It's this many miles long, but really I still have no clue because I've never seen a number that big, and it's this many feet long. I won't even try to pronounce those. But in the vastness of our universe, in the humongous nature of it, only about 5% of that is actually stuff, ordinary matter. About 20% is dark matter, we think, and then the rest is just space, universe. Within this vast, magnificent universe, there's 1 septillion stars. That's 1 with 24 zeros behind it, amount of stars. And let's take the small star in our solar system as an example. Our star in our solar system, which we call the sun, which God calls the sun, emits about 3.8 times 10 to the 26 watts of energy. That's 4 with 26 zeros behind it, watts of energy. That's every second. A 1 megaton nuclear bomb, which would be devastating to any of us near it, is approximately 4.18 trillion watts. And so that means that 10 or about 11 trillion 1 megaton nuclear bombs go off every second in the sun. And our sun is tiny compared to other stars in our universe. The black hole at the center of our Milky Way, which was once a star, which we call Sagittarius A star, has a mass 4 million times the mass of the sun. Imagine how many nuclear bombs that star would have emitted. Our universe is magnificent, and God created it all. On day number 5 in verse 20, then God said, "Let the waters swarm with living creatures, and let birds fly above the earth across the expanse of the sky." So God created the large sea creatures, every living creature that moves and swarms in the water, according to their kinds. He also created every winged creature according to its kind, and God saw that it was good. God blessed them, "Be fruitful, multiply, and fill the waters of the seas, and let the birds multiply on the earth." Evening came, and then morning, the 5th day. We've examined God's creation so far from the perspective of fluid mechanics, from structural mechanics, from astronomy, biology, physics, and even botany. And now we're going to examine it with thermodynamics in mind. Something that you use every day, but probably don't even realize it, is a heat exchanger. That comes in various forms in our everyday life. Probably the one you use most often is the radiator or the condenser coil in your car. A heat exchanger allows two fluids at two different temperatures to heat transfer from the hotter fluid to the colder one. And we use this in engineering and heating and cooling air for our houses, refrigeration, ventilation, so many more things. But heat transfer in our world occurs in a heat exchanger by two main ways. The first is conduction. As hot fluid, this is a intercooler for a turbocharger, but imagine this was the radiator in your car. Hot fluid comes into this radiator, and there's a plate in here, and that water goes over this plate. And so heat would then go from this plate into all these tiny little fins, which you've probably seen on your radiator, and that heat conducts through the metal and into those fins. The second mechanic of heat exchangers is convection. Cold fluid then flows, depending on how fast you drive, for some very fast and others very slow. Cold fluid flows over those fins, increasing the temperature of increasing the temperature of the cold air. So every time you drive your car and you turn on your air conditioning, you're actually heating up the world. And every time you turn on the air conditioning in your house, you're heating up the universe just to cool down your house. And so the cold air increases in temperature. The hot fluid from your radiator decreases in temperature. But as it turns out, God actually came up with this concept first. On day number 5, God creates these water animals. And I picked one. The dolphin fin is actually a very efficient heat exchanger. It's primarily used for locomotion and enabling it to move and swim and do all types of dolphin stuff, I guess, jump out of the water. It's used for stability, but it's actually a pretty good natural heat exchanger as well. You can see here that as blood is pumped into the dolphin's fin, it is acting as that hot fluid from the radiator. Cold water would then pass through it very rapidly, cooling down the fin. Thus, the blood would then go into the rest of the body, and it would cool down the rest of the animal. We sweat, and then that sweat evaporates. That's how we cool down. Dolphins use a finned heat exchanger like the one in your car. And so on day 5, God creates all types of water animals and birds. And this is just one example of the magnificence, the insight behind God's creation. God is life-giving here on day 5. He is the source of life. Where did life begin? To this day, the only way we've been able to create life is through what we call biogenesis, or life comes from life. Life has never in any of human experience come from anything other than non-life, except for Jesus of Nazareth through Mary, and that was only half. And then on day 5, you also see that God is problem solving. In verse 2, I don't know if you noticed, but there's 3 problems listed with earth. It is without form, there's no order, it's empty, it's void, there's nothing on it, and there's darkness over the face of the deep, there's no light. Here on day 5, God resolves all 3 of those problems. God creates light to dissipate darkness on day 1 and day 4. He orders his creation in verse 6 and verse 10, waters above and waters below, a sky. He orders his creation to have earth and sea. And here, he's filled the emptiness of the earth with plants. He's filled the emptiness of the heavens with the sun, the moon, and the stars. And he's filled the emptiness of the sea with fish and the emptiness of the sky with birds. On day 6, in verse 24, then God said, "Let earth produce living creatures according to their kinds, livestock, creatures that crawl, the wildlife of the earth according to their kinds." And it was so. So God made the wildlife of the earth according to their kinds, the livestock according to their kinds, and all the creatures that crawl on the ground according to their kinds. And God saw that it was good. Then God said, "Let us make man in our image, according to our likeness. They will rule the fish of the sea, the birds of the sky, the livestock, the whole earth, and the creatures that crawl on the earth." So God created man in his own image. He created him in the image of God. He created them male and female. God blessed them, and God said to them, "Be fruitful, multiply, fill the earth, subdue it. Rule the fish of the sea, the birds of the sky, every creature that crawls on the earth." God also said, "Look, I have given you every seed-bearing plant on the surface of the entire earth, every tree whose fruit contains seed. This will be food for you. For all the wildlife of the earth, for every bird of the sky, for every creature that crawls on the earth, everything having the breath of life in it, I have given every green plant for food." And it was so. God saw all that he had made, and it was very good indeed. Evening came, and then morning, the 6th day. On day number 6, God creates the livestock, the creatures that crawl, all of the wildlife of the earth. And then the pinnacle of day 6, the pinnacle of all of his creation, is he creates man in his own image. One of the fascinating things that, I'm not a biologist by any means, but I like mechanical systems. I'm a mechanical engineer. And what we've determined is that biology is really a study of mechanical systems, of different proteins and lipids and all different types of structures coming together to form the very fabric of life. Here on day number 6, God would create a natural process which we would call cellular respiration. Our cells need energy to live and to survive. That's why we eat. Within these cells are a power plant. Does anyone know what the power plant of the cell is? If you remember from high school? Mitochondria. In the mitochondria, which you can see there, and then that's pretty blurry, but I think that's that. In those mitochondria, these mitochondria produce ATP, adenosine triphosphate. ATP is the whole goal of cellular respiration. It's needed for life and energy, and it's created by a very interesting process. Cellular respiration begins with a process called glycosis. Glycosis takes place in the cytoplasm, the kind of jelly stuff in the cell, and it creates that from glucose, sugar, things you eat, and that sugar is broken down in the cytoplasm into pyruvate and an electron carrier called NADH. The Krebs cycle then takes place within the mitochondrial matrix, so within that structure there. And within that matrix, pyruvate is further broken down, so glucose is broken down into pyruvate, and an electron carrier, that's further broken down then into carbon dioxide. That's why you exhale carbon dioxide. Whatever number of trillion of cells do that, and so that's a lot of air that's produced by this process. But then more electron carriers are produced, NADH and FADH2. And then we arrive at the ATP production factory, the actual powerhouse, which is this ATP synthase. It's an enzyme, and this is the process that governs life. This is the process that ensures you wake up in the morning and are still living, your heart is still beating. And so this process is taken to the wall of this mitochondrial membrane, the inner mitochondrial membrane. NADH and FADH2, which were the byproducts of pyruvate, which are now donating their electrons to an electron transport chain. That transport chain are clung to this chain, and you have a gradient. On one side, you have a high concentration of electrons. On the other side, you have a low concentration. As you might remember, through a process called osmosis, most things want to go from high concentration to low concentration. And so these electrons move through this little stator here, and there's actually kind of fins on it, like you would think about a water wheel as water moves over it. So as each electron successfully turns and moves through here, it turns that water wheel, which turns this axle here. You can actually see that happening here. And in this little structure here, you have ADP and a phosphate group. The ADP and a phosphate group are smushed together, and that creates ATP. And within this ATP synthase, up here, there's little cylinders, you might think of them, like a radial airplane engine would have cylinders that compress in all different directions, and that's what produces the propeller spin. Here you have that same thing, so there's a piston there, a piston here, a piston here, and that smushes the ADP and phosphate group together, creating ATP. And this is on a level which we can't even see with a microscope. This is a level which we can't even imagine to see with our eyes. But yet here we have an extremely efficient motor. An extremely efficient motor that engineers are very jealous of, 80 to 99% efficient. Your cars are anywhere from 6 to like 15, 20% efficient on the upper end of the scale. Here's a motor that's 99% efficient. And the byproduct of doing all of that, combining the electron carriers are then taken out, they form and they bond with an oxygen, and you take two hydrogens and an oxygen, you bond them together and you get water, H2O. That's what you pee out every day. That is the byproducts of cellular respiration, is water and CO2. And so now energy is stored in the mitochondria's protein, and that protein, which now has like 40 ADP in it just from one carrier, as that is produced. God is amazing. A God not like us. Who would have thought to create something like this? Who would think that this comes from natural processes, that change created change, and slowly over time with enough energy and time that something like this would be created? Our God is amazing, but He is a God not like us. God is compassionate. All of the effort, biology, design, and engineering that goes into life is for His creation, not for Him. He cares for the needs of His creatures, and we also see that God is relational. He desires relationship with His creation. He desires that humanity, the animals, the plants, the fish, they all reflect His goodness. He says on day 6, not just that it was good, but that it was very good. Humanity reflects the goodness of God and was created to do so from the beginning. So as we start thinking about Acts chapter 17 again, Paul told that perceptive people of Athens who failed to fully find God, to seek the Creator of the heavens and the earth, and to learn His nature. Again in Acts chapter 17, in verse 27, he did this so that they might seek God, and perhaps they might reach out and find Him. Though He is not far from each one of us, for in Him we live and move and have our being. As even if some of your own poets have said, for we are also His offspring. Since we are God's offspring then, we shouldn't think that the divine nature is like gold or silver or stone, an image fashioned by human art and imagination. We serve a God who created all of His creation to reflect His nature of power, order, love, compassion, creativity, problem-solving, perfection, life-giving, wisdom. And so Paul doesn't just tell those perceptive people in Acts chapter 17 to seek God, to seek His nature. He tells them that we serve a God that we are like. We serve a God that He's not like us. He's not in the temples. He's not in the idol shrines. We don't bathe Him. We don't feed Him. We don't do all of the things that those in Athens would have been doing to the stoas around the city. But yet He is a God that we are like. Does that mean, though, He has a head, hands, ears, feet, that we're made in His image? Well, in Genesis chapter 1, verse 2, we read that the Spirit of God hovered over the face of the waters. God is Spirit. But yet here, God creates in His image to reflect His nature, to reflect His qualities, His characteristics, His goodness. God created His pinnacle of creation to share in His nature, to have the very characteristics and qualities that we've looked at. God reveals His nature to us every day we're alive. Through His creation, through His grand book. Not this book, but the book that He created on the first literal 6 days of creation. Will you seek that God? A God of goodness, of wisdom, of compassion. Will you seek His nature? Let it change the way that you live. Paul again doesn't just end in Acts chapter 17 by saying that we should seek God. In verse 30 he says, "Therefore, having overlooked the times of ignorance, God now commands all people everywhere to repent. Because He has set a day when He is going to judge the world in righteousness by the man He has appointed." Do you remember that we said that God is a God of division? He creates the light and He separates light from darkness. He creates the dry land and He separates that from the sea. He creates the waters above and separates those from the water below. God is a God of division when it comes to sin. No one can enter into Him with sin. But yet you were created to reveal, to live in His nature, in the image of God. How are you doing at that? Do you have sin in your life? Have you at one point come to God, come to Jesus, understanding that His nature is all around us and that He is a good God, and you put your faith in Him, were baptized into Christ's blood, but yet you're living a sinful life away from God, away from His nature? We can help you tonight. We can pray for you, we can study with you, we can talk with you. I know the brethren here will be more than happy to do those things with you. If you've never put your faith in Christ, if you've never put your faith in the God of nature that we see all around us, we can help you study and learn how to do that. Learn how to serve our magnificent, good God. If we can help you in any way this evening, would you come to the front as we stand and sing?